Today we're going to look at factoring polynomials. We have already looked at some problems from our pre-worksheet for this unit that we started after the test, and it was basically on the greatest common factor. Some of the problems from the greatest common factor worksheet were to take out the greatest common factor between 5x minus 20x squared, so they can both be divided by the number 5, and they both share an x, so that is going to leave us with 1 minus 4x. Number 4, we had ab squared plus 4b squared. We can take out a b squared from both of those, and we are left with a plus 4. If we have multiple variables, we can pull c squared from both of the terms, and we can also pull a d squared from both of the terms. So that leaves me with c squared plus d. Here I can pull a 5 from both of these, so that will leave me with 3a plus 5b. I'm going to skip ahead to some of the other problems. Of number 22, I could factor out an x squared, leaving me with x squared minus 3x plus 17. On number 24, I could factor out a 5a squared, and that's going to leave me with a squared minus 1 plus, I can't factor out an a squared, I can only factor out an a, so it's going to leave me with a to the third minus 1a plus 25. Number 30, I could factor out a 13. They all share at least an a, and they all share at least a b, so that's going to leave me with a squared b plus 3a minus 2b to the third. I can factor out a 7 and a c, leaving me with c squared minus 4cd plus 5d squared. And the last one, I can factor out an m and an n, leaving me with 1 plus 5mn minus 12mn squared. Whenever we are factoring trinomials, we are always going to look for greatest common factor first. Then we'll look to see if there are any special patterns. We'll look to see if we can factor by groups, or we'll use another type of method to factor. And this method is just simply your organizational thoughts. Some teachers call it tic-tac-toe, a factor diamond, an X method, the box method. Whatever you call it, whatever method you use is perfectly fine. I'll be using what we call the X method, or the AC method. X squared plus 12x plus 20. I'm looking for two factors, or binomials, that will multiply together to give me 20 and add together to give me 12. So multiply to get 20, add to get 12. I've got 1 and 20, 2 and 10, 4 and 5 as my options. Since 2 times 10 is 20 and 2 plus 10 is 12, 2 and 10 are the two numbers that I'm going to use. Whenever this is a basic trinomial to factor, means that I have 1x squared here. I can take these two answers and simply write them down as my factors. X with a plus or positive 2 and x with a plus or positive 10. Now my two factors are here. If I FOIL this out, it gives me the answer x squared plus 12x plus 20. This next one, I'm looking to multiply two numbers to get negative 20 and add to get negative 1. That would be negative 5 and positive 4. So that would be x minus 5 and x plus 4. X squared minus 4xy minus 12y squared, just because I have an xy in the middle and a y squared at the end doesn't change the process. It's still a basic trinomial. So I'm going to multiply to get negative 12 and add to get negative 4. That would be a negative 6 and a positive 2. So I will have x minus 6 with a y and x plus 2 with a y, and that will give me my negative 4xy in the middle and my y squared at the end. 14x squared minus 17x plus 5. I do not have a greatest common factor. This is not a basic trinomial now because I have a number bigger than 1. So this is an advanced trinomial. And with an advanced trinomial, we have an extra step to add. Instead of multiplying to get just 5, now we're going to have to multiply to get whatever 14 times 5 is. Because we have this extra number up front, we have to worry about including it. So 14 times 5 is 70. So I need two numbers that multiply together to give me 70. Still going to add together to give me negative 17. So multiplying to get 70, adding to give me negative 17 would be negative 10 and negative 7. This next step is the added step that we have, and it's rewriting. I'm going to take the number negative 17x, and I'm going to rewrite it as negative 10x and negative 7x. This will allow me to have 4 terms instead of just 3. And having 4 terms allows me to factor by groups. Factoring by groups, I would break it up into 2 sections and then look at the greatest common factor for each piece. So 14x squared minus 10x both have a 2 that can be divided out, and they share an x. So now I'll have 7x minus 5 as my inside of parentheses. Negative 7x plus 5, the only number that they share in common is a 1, but because this is a negative, I'm going to divide out a negative 1. And that's going to leave me with positive 7x minus 5. So the common part comes to the front, 7x minus 5, and what's left over goes to the back, 2x minus 1. And there's my factored form. Let's get to another one. 54a to the third b squared c squared minus 36a b to the third c to the fourth. I'm simply going to look for a greatest common factor, and I can divide both of these by 18. I'm looking for how many factors of a I can pull. I can pull 2 factors of b, and I can pull 2 factors of c. That's going to leave me with 3a squared. I don't have any b's or c's left in the front. Minus 2, I don't have an a left. B, c squared in the back. Let's see. X squared minus 6x plus 9. I notice that this is a perfect square and this is a perfect square, so I may try to see if it is a pattern that will work for perfect squares. Perfect square pattern means that I've got the root number of 9 is 3 and the root number of 9 is 3, and I'm trying to multiply 2 numbers together to get 9, add to get negative 6. So they would be negative 3 and negative 3. The pattern here is that the root number of 9 is 3, and when you take the front term x times the back term 3 and double it, you end up with 6x. These are more basic trinomials. Here's another advanced. So I'm trying to multiply to get negative 8, add to get negative 7. That would mean I would have to multiply negative 8 and positive 1 to add together to get negative 7. So now I'm going to rewrite. So many of you have heard the acronym MARF. Multiply, add, rewrite, factor by groups. So we multiply to get negative 8, added to get negative 7. Now we're going to rewrite. So I have x squared minus 8x plus 1x minus 1. And then factor by groups. If I take out an 8 and an x, I'm left with x minus 1. And out of the back part, the only thing that I can take out is the 1. In factor by groups, you have to have 2 factors for your front group or set of numbers and 2 factors for your back group or set of numbers. So that means that if I need to pull out a number, I have to pull out something. I can use the number 1. The common factor of x minus 1 comes to the front, and then what's left over, 8x plus 1, goes to the back. Now, the next thing that we're going to look at is special patterns, and this is special patterns of squares. What this is saying is that I have a front number that is squared. I may have a back number that is squared. Sometimes I have something in the middle, sometimes I don't. If I have something in the middle, then I would check to see if the front number times the back number doubled would give me the middle number. So whenever I had x minus 3 and x minus 3, it came out to be x squared minus 6x plus 9. So the front times the back doubled gives me the negative 6x. In this one, it's a difference of two squares, and that is this pattern right here. It tells me to take the root of the front, so the root, or where x squared comes from, it comes from an x, and the root of 49, or where 49 comes from. 49 is a perfect square for the number 7, and it's going to be placed twice, x and 7, x and 7. The difference of perfect squares has the pattern where one of the factors is a plus, one of the factors is a minus, and that is our answer. If I were to go through and distribute or FOIL this, then my x times x gives me the x squared, my outside and inside added together would give me 0, and 7 times negative 7 would give me negative 49. This one, 46x squared minus 16z squared, I notice that this is a perfect square and this is a perfect square. So 64 as a square comes from the number 8, and x squared comes from x. 16 comes from the number 4, and z squared comes from z. So I would have 8x plus 4z and 8x minus 4z. This can still be divided by 4, so I could take out a common factor of 4 and leave me with 2x plus 1z. And this can still be divided by 4. So if I take out another factor of 4, 4 times another 4 is going to give me 16 up front. This is 2x plus 1z, and now this one is also 2x plus 1z. The other option for this would have been to recognize that I could have taken out a 16 from both of these first, and that, not z squared, just 16, and that would have left me with 4x squared minus 1z squared, and then this would have been a difference of perfect squares. 4 comes from the root 2, 1 comes from the root 1, so I get the same answer. This one was fewer steps if I take out the greatest common factor first, but if I don't recognize the greatest common factor right away, then I can always take it out later. Let's look at this one. 9x squared minus 100 is going to give me the root of 9 is 3. The root of 100 is 10. So this one is going to be 3x minus 10 and 3x plus 10 because it's two perfect squares, it's a difference in between, and that way whenever I multiply, I would get opposite pairs of 3x or 30x and negative 30x, which would add to give me the 0 x's in the middle. Factor by grouping, we already looked at a little bit. We look for the greatest common factor, split it into two parts, factor out the GCF from each part. The common factor goes to the front, and anything that's left over goes to the back. So anytime you see 4 or more terms, we're going to try to factor by grouping. So x to the third minus 2x squared will be grouped together, and negative 4x plus 8 will be grouped together. I can take an x squared out of the front, leaving me with an x minus 2, and I can take a negative 4 out of the back, leaving me with an x minus 2. The common part, x minus 2, comes to the front, and what's left over goes to the back. We have to check to make sure, since I still have an exponent here, that I can't break this down anymore, and in this case, I can. The second part is difference of squares, so I can break that down into an x minus 2 and x plus 2. Second example, I can take out a 2 and an x squared from the front, leaving me with 2x minus 3. I can take out a 5 from the back, leaving me with 2x minus 3. And that's going to be 2x minus 3 times 2x squared plus 5. More factor by grouping problems. This one is now the sum and difference of cubes. The sum and difference of cubes is a pattern that we can create if we see that the front part is a perfect cube and the back part is a perfect cube. What we're going to do is we're going to say what is the root number of this x to the third. And x to the third comes from the root x. So that's our front portion of our answer. And we ask what is the root number of 8. 8 comes from the root number 2. So 2 is the back portion of our answer. Then, once we have these two numbers, we're going to be able to build the back part of our answer. So we use the front part of the answer, and it says we take that front value and we square it. So this becomes x squared. Then we take the front times the back to give us 2x, and then we take the back part and we square it. So 2 squared is 4. Now we go back and we put the signs in, pluses and minuses. What's nice is that we're going to use an acronym like SOAP to tell us what type of signs to use. S is for the same sign as our original problem, so this one would give us a plus. O is for the opposite sign, so that would be a minus. And then AP is for always positive, so the last one is always going to be positive. And that works for sum or difference of cubes. So this next problem we'll do, since that one's very similar, we'll do this one. 8x comes from the root 2x. So 8x third comes from the root 2x. 27 comes from the root number 3. Now that I have the front, I'm going to build the back. So the front part squared, 2x, the whole thing squared, is going to be 4x to the second power. Front times the back is going to give me 6x, and the back squared will be 9. Then I go back and use my signs. Because this was a minus, I'm going to use the same sign, minus, opposite sign, plus, always positive. And now both of those are factored. We sometimes have to take a greatest common factor out first. So in this case, I would take out an x, leaving me with x to the third plus 8. Then I would have to build my front. The root of x to the third is x. The root of 8 is 2. Then I use that to build the back. The front squared would be x to the second power. Front times the back is 2x. And the back squared would be 4. Go back and do my signs. Same, opposite, always positive. A to the sixth minus 64. This problem can be done two different ways. What we want is either a difference of squares or a difference of cubes. The number 64 is a perfect square for the number 8, and it's a perfect cube for the number 4. So it really doesn't matter which one we start with. I'm going to do perfect squares. That means that I want to rewrite a to the 6th as a to some power to the second power. And then the 64 comes from the root number 8. Exponent rules say when you raise a power to a power, you multiply those two numbers. So in order for me to multiply to get 6, this is going to have to be the number 3. So using difference of squares, the root number of a to the 6th is going to be a to the 3rd, and the root number of 64 is 8. Once I have the front, I would build the back, and that would be, this difference of squares. I'd have a to the 3rd minus 8 and a to the 3rd plus 8. Then that gives me difference in sum of cubes. So difference of cubes, the root a to the 3rd comes from a, the root number 8 comes from 2. Then I would build the back. So that's going to be a squared, 2a, and 4. Same sign, opposite sign, always positive. And the a to the third plus 8 is a sum of cubes. So that would be a and 2. And then I'd have a squared, 2a, and 4 again. Same sign would be a plus, opposite sign would be a minus, and then I'd have always positive. So for this, I have a minus 2, a plus 2, a squared plus 2a plus 4, and a squared minus 2a plus 4. So that is the factored form for a to the 6th minus 64. I could rewrite this one as difference of squares. So I would have 4x squared to the second power minus 9 to the second power. So the root of 16x to the fourth is 4x squared, plus the root of 81 is 9, and I'd have 4x squared minus 9. So I use my difference of squares pattern first. 4x squared plus 9 can't be simplified, but 4x squared minus 9 is another difference of squares, so that's going to break down to 2x plus 3 and 2x minus 3. Y to the 6th minus 9 would give me, I could use difference of cubes or difference of squares, so I'm going to let this number decide which one I want to do. 9 is a perfect square, so I'm going to use difference of squares. So I want y to the third squared minus 3 squared. So y to the 6th comes from the root y to the third, and 9 comes from the root 3. So I have y cubed minus 3 and y cubed plus 3. Now, this would be nice if it were a difference of cubes, so I could break that down, or a sum of cubes, so I could break that down, but 3 is not a perfect cube, so I can't break this down anymore. Y to the 6th minus 8. Again, the number 6 I could break down into perfect cubes or perfect square, but this number tells me I want to use perfect cubes. So now I'm going to have y squared to the third power minus 2 to the third power. So y to the 6th comes from the root y squared. 8 comes from the root 2. So that's the front. The back is going to be the front part squared, so that would be y to the 4th. Front times the back, 2y, and then the back squared, which would be 4. Go back and look at the signs. I would use the same, opposite, always positive.